Good morning. In this class, we see about what is the first step of the FEA. That is like a discretization of structure. The last class we see about the 10 steps we have to study with the what are the steps we are doing for the FEA, that is finite element analysis or finite element method. Okay. In this class, we did about only the specific problem for we are taking for the discretization of structure. Okay. So the first of all, the art of subdividing a structure into a convenient number of smaller element is known as a discretization. Okay. So for example, I told you know, if I consider one single rectangle, okay, I consider as a two element. So either you have to consider three element or four element, five element, whatever. Okay. If you have a 100 mm, no, the 100 mm you have to cut into any number of equal parts. Okay. So that is a process called as a discretization. That is you have to convert as a small element. Okay. That is called as my main part of a discretization. And also the smaller element we have to classify into four, that is one-dimensional element, two-dimensional element, three-dimensional element, and the axis symmetric element. Okay, so one-dimensional can be deal with only one axis, and the two-dimensional element we have to dealing with the one x-axis and y-axis, and three-dimensional we have to consider three axes, that is x, y, z, and the fourth we have to consider about the axis of revolvation. Revolvation of the element, we call it as the axis symmetric element. Okay. So, for example, here I consider the one element. Okay. So, if I consider one element bar, it having a node numbers 2, that is 1 and 2, I represent node. The node number we have to difference as only the edge of the bar. Okay. For example, 1 and 2. So, this is my element number 1. Okay. And also, if you are considering one element bar, the one element bar has been considered as a one a dimensional element. For example, you consider two element or three element, whatever. Okay. The simplest line element is also known as a linear bar element as a two nodes of the one element. Okay. That is as shown in figure. This is also called as my bar element. Okay. So two-dimensional element is like a triangular element or rectangular element. Okay. For example, the triangular or rectangular element are considered for the two-dimensional analysis. These elements are noted by the focusing their own places. So, for example, here I consider the simple element is like a say, triangular element or rectangular element. Okay. So 1, 2, 3 and 1, 2, 3, 4. Okay. If I consider the triangle element 1, 2, 3, okay, the each node having a two displacement function. For example, this is a two-dimensional problem. Okay, so you have to consider the two displacement and two force matrix for the each node. For example, for one having you have to define no. So it's a based upon x-axis and based upon y-axis. So similar to based upon x-axis and based upon y-axis. Similar three also. And similar, you have to, for casing for the rectangular, you consider the four. Okay, that is x and y, x and y, and x and y. Okay, for the each node, that is each number. Okay, so the each number you have to define, either you have to define the x-axis or y-axis. So these are the basic concept. Okay, these are the basic concept for the one dimensional and two dimensional for the discretization matrix. Okay, so this is the most important for your analyzing problem. So you have to classify, you have to define the material, and also after that you have to do the discretization of the structure. So I have to doing for the problem in one dimensional cases or two dimensional cases or three dimensional cases. So case by case it will be changed. Okay. The next one I told you know the three-dimensional problem. So whenever you have a three-dimensional problem, the most commonly the three-dimensional element are the inherited and வந்து பார்த்தா hexahedral is like a brisk element. The I have to right side show the figure. Okay, these elements are using for the three-dimensional stress analysis problem. So this is the simplest three-dimensional element having a node has been shown. Okay, for example, here considering the tetrahedral element and the hexahedral element. So tetrahedral element is like a triangle, is like a cube, okay, and it's like a brisk, that is a hexahedral, okay. And axis symmetric element, this is the axis symmetric element is developed by the rotating a triangular or quadrilateral, okay, triangular or quadrilateral about a fixed axis in the plane of element is throughout the 360 degree, as if it is shown in the right side figure. Okay, you have to see, no, that is when the geometry or loading the problem or axis symmetry, these elements are mostly frequently using for this case. Okay, so whenever if you are dissolving the discretization structure, you have to classify as a one-dimensional, two-dimensional, and three-dimensional element, and also the last one is axis symmetric element. So based upon the these kind of elements, okay, they call it as a discretization structure of element. Thank you.